Every year, billions of birds embark on epic journeys across continents and oceans. Tiny songbirds, weighing just a few grams, navigate vast distances, returning to the same breeding and wintering grounds year after year. How do they do it? What incredible navigational abilities allow these creatures to find their way across such vast expanses? Early theories proposed a range of explanations, from birds hitching rides on ships to following land formations. However, it was clear that something far more extraordinary was at play. The Arctic tern, for instance, undertakes the longest migration of any animal, traveling from its Arctic breeding grounds to the Antarctic and back each year, a round trip of around 44,100 miles. These incredible journeys demonstrate the power of natural selection, shaping remarkable adaptations that allow birds to thrive in a constantly changing world. By understanding the factors influencing these journeys, we gain a deeper appreciation for the delicate balance of ecosystems and the importance of conservation efforts to protect these remarkable creatures and their migratory routes. One of the most remarkable discoveries in avian navigation is the existence of a magnetic sense in birds. This ability allows birds to sense the Earth's magnetic field, providing them with a compass-like orientation. Scientists believe that this magnetic sense is based on specialized cells in the bird's eyes or beaks that contain iron-rich crystals. These crystals align with the Earth's magnetic field lines, sending signals to the bird's brain to determine direction. This magnetic compass is incredibly sensitive, allowing birds to detect even subtle variations in the Earth's magnetic field. Experiments have shown that disrupting a bird's magnetic sense can disorientate it, causing it to lose its way. Researchers have manipulated magnetic fields around birds in captivity, observing how their orientation and navigation are affected. The discovery of the magnetic sense in birds revolutionized our understanding of animal navigation. In addition to their magnetic compass, birds also rely on celestial cues, such as the sun and stars, for navigation. By using the sun's position in the sky, birds can determine their latitude and maintain a constant compass direction. Birds have an internal clock that allows them to compensate for the sun's movement throughout the day, ensuring accurate navigation. At night, stars provide a reliable navigational guide. Birds learn the patterns of stars in the night sky and use them as fixed points for orientation. Studies have shown that young birds learn these celestial patterns from their parents or other experienced birds during their first migration. The ability to use both the sun and stars for navigation provides birds with a robust and flexible system. Their ability to switch between different cues ensures that they can maintain their course even in challenging conditions. The sun's position in the sky provides birds with valuable information about their location and direction. As the Earth rotates, the sun appears to move across the sky, reaching its highest point at midday. By sensing the sun's angle and its movement throughout the day, birds can determine their latitude and maintain a consistent heading. This ability to use the sun as a compass is known as sun compass orientation. Birds have an internal clock, known as a circadian rhythm, which allows them to compensate for the sun's movement throughout the day. Experiments have shown that birds can be tricked into misjudging the sun's position, causing them to fly in the wrong direction. By manipulating the light-dark cycle in a bird's environment, researchers can shift its internal clock, leading to disorientation. The sun compass is a vital navigational tool for many migratory birds, particularly those that travel during the day. Beyond their magnetic and celestial compasses, birds also rely on a suite of other senses to navigate their surroundings. Their keen eyesight allows them to detect landmarks such as mountains, rivers, and coastlines, which they use as visual cues to guide their flight paths. Birds have an exceptional ability to remember these landmarks, even after long migrations. Their sense of smell also plays a role in navigation, particularly for homing pigeons. It is thought that pigeons create olfactory maps of their surroundings using scents carried by the wind to navigate back to their lofts. Furthermore, birds are sensitive to infrasound, which are sound waves below the range of human hearing. Infrasound can travel long distances and is generated by a variety of sources, including ocean waves, wind patterns, and even earthquakes. The integration of multiple sensory cues allows birds to build a comprehensive picture of their environment, enhancing their navigational accuracy and flexibility. The study of bird navigation is an ongoing journey of discovery. While we have made significant strides in understanding the mechanisms involved, many questions remain unanswered. Scientists are still unraveling the precise workings of the magnetic sense and how birds learn and calibrate their internal compasses. As technology advances, researchers are developing new tools and techniques to study bird migration in unprecedented detail. Miniaturized tracking devices allow scientists to follow individual birds on their journeys, providing valuable data on their flight paths, stopover sites, and the environmental factors influencing their movements. As we delve deeper into the mysteries of avian migration, we gain a deeper appreciation for the interconnectedness of our planet and the importance of protecting the natural systems that sustain all life, including our own.